Cool. Let's do it.
All right. Welcome, everyone, to our monthly SLDS series. My name is Jamie Spicer. I'm an assistant professor at Wake Forest School of Medicine, and I'm organizing this webinar series that is sponsored by the section on statistical learning and data science of the American Statistical Association. Today, we are honored to have Wayne Lee talk about data science careers and industry. Dr. Wayne Lee is a lecturer at Columbia University and is interested in scalable statistics education. Wayne received his PhD in statistics in 2013 and practiced data science in companies like LinkedIn, the Climate Corporation, and United Technologies. His professional projects range from product analytics, academic research, data quality, and consulting. The talk will be about an hour. During the talk, please type questions in the chat box and I will pause Wayne and ask them as the presentation goes along. And additionally, we should have about 30 minutes for discussion at the end of the talk. The webinar is being recorded and will be available on the section website. I'd like to thank our speaker and the sponsor of this webinar, the Statistical Learning and Data Science section of the American Statistical Association. And Wayne, I'll turn it over to you.
All right. Thank you, Jamie. Great to see everybody here. I guess I can't really see you, but hopefully you have lots of questions from today. It's really meant to be somewhat a little bit informal, and hopefully you'll hear some interesting things that you might have not expected. But my main thing is data science out of tech. All right. So a rough outline. First, I would talk about probably the classic data science in tech just a little bit more. And I know some of you are very tired of that. But I'll give you a little bit of inside scoops from my past experiences. I'll talk about some common tech mistakes when you practice tech outside of tech. And obviously provide you some opportunities for statistically minded people. I really think there's a lot of opportunities outside of the tech space in general. So again, just data science. My kind of data science journey started in the digital world at LinkedIn. I did the A/B testing platform there. So if you ever worked at LinkedIn, their A/B testing platform they initially used was built by my first team there. Not my team, I was on the team. And honestly, it started off with just doing the t-test. And I thought this project would be over in 3 months. It actually took us a whole year just to get the first version out and used by the company. So that was very exciting. I moved on to agriculture. That's what the Climate Corporation does, and is now a subsidiary of Bayer, and was previously a subsidiary of Monsanto, if you're ever curious about that. Then later I moved to United Technologies. If you've ever been on a plane, they basically build a lot of the parts that provide for planes, and they are now part of Raytheon Technology. And I am now at Columbia University trying to really understand how education and statistics kind of work together really here. So when I talk about outside of tech, my experience is mostly in agriculture and heavy manufacturing. But I do think a lot of these lessons do apply outside, like things like restaurants, healthcare, education, energy, construction, transportation, etc. So think about these industries as, I would say, things that existed before the internet and hopefully will exist after the internet as well. So one key thing we should really just, I think, be upfront and clear about is that data science, what is it? It is the basically job that converts money into value, okay? And I think the big question is that data has been around for quite some time, right? Fisher was running experiments in 1920s and so on and so forth. So like, what is the new, what's new here, right? And so I would argue that the new thing, the change, not only is it just overwhelming big data, it's everywhere, et cetera, but mainly that data itself is now a primary asset that you can sell. It's not just a derivative to monitor that there's no problems in the actual product, but the data itself has value. Once I have enough data about enough people's resumes, I can build a company called LinkedIn and somehow be the largest professional network out there in the world, and be acquired by Microsoft later. So So I would say that has been a pretty interesting shift now in terms of how people view data and why the role of data scientists is interesting. Okay. And there are many, many other people who have data in their titles, and obviously more than one role that generates value out of data. And so just to touch on these a little bit, a data analyst, I would say, is more of an internal role. So you are there to provide kind of measuring the heartbeat of the company and maybe probe what are new markets that the executive team wants to go in. But you're very much providing a analytical framework to an existing company, existing product, etc. A data scientist is a little bit more external, where you actually have to be more innovative in general and trying to explore what are intersections between different fields that could provide new value, etc. A data engineer to me is more of like a plumber. So the data science team needs all the historical data queried in one go, whereas the product team, the customers are only querying the data one row in the data at a time, right? But they need the most up-to-date data. So if I publish a LinkedIn article today, right now, I expect all my connections to be able to see it within seconds, right? And that's a very different use case from if I'm a data analyst at LinkedIn trying to say, okay, well, how many articles has this person written? And when we show their articles to certain people who respond to them, that type of querying pattern is very different, and data engineers need to know, how do I do the piping there to make that happen? A data architect actually gets even more complicated. I would say it's like a higher level of a data engineer, where once you have all these different data interacting with each other, what is the most efficient and kind of logical way to structure all the data? And that's like, I would say, much, much later for big companies that have these problems. And the last funny one is a consultant. And this is actually becoming more and more common because a lot of people don't actually want to hire necessarily data scientists because they don't really know what they're going to do with the data. They kind of have an idea of how they're going to start their company. Do I actually need a data person in my founding team? And so they'll probably hire consultants, and these consultants will try to use data to help you maybe measure the market you're going into, give you some kind of data strategy, etc. Um, but they don't actually have to execute. They very much just provide the guidance and be like, here's what other companies have done, here's what you can do as well. Maybe my experience in the past can help you as well, but I may not have to execute that plan with you. And therefore, the plan can be sometimes a little bit um, dreamy, I should say. So that's kind of different. And some notable trends in data science I should just note is that data scientists and executives are both frustrated. And if you have not heard this before, um, you should basically be pay a little bit of attention. But data teams often find that executives don't really understand data or that want data to do magic for them. Whereas executives are frustrated because they're literally throwing in millions of dollars and they're not quite seeing the return that they're hoping to see. Everyone's hoping to see, multipliers like Facebook and Google are seeing, but those are very much concentrated in the advertising world, at least at the moment. Um, so there is these, I would say, like tension in the role of a data scientist and practicing data science. And this article itself, I think, advertises to just have a role that does the communication in between. I personally actually highly disagree with that recommendation, but that's another day's topic. So one thing I want to talk about is that what we teach in school about data science is often just about models and model building. And here's a slide to just let you know that that job is going away, right? If you can only just run models, throw data into a model and, get the model out afterwards, there's companies out there that are trying to build products to automate that job away. Okay, Databricks, Data Robot, even just the scikit-learn library. Many startups use that, H2O, H2O, etc. There's also a lot of, I would say, analytics companies that basically create dashboards So if the product manager knows what data they want to look at, which there are very quantitative product managers, they also have a whole suite of companies that want their business, right? Google Analytics, Power BI, Tableau, and there's like Looker nowadays and other things. Um, on the other hand, right, if you get lucky, you might be able to define the data protocol. So my job at LinkedIn back in the days when we were defining the A/B testing platform, the first question was, what's the data that like everybody is using? And the number one surprise was that the definition of a page view is very different. So on the mobile app, on a phone, if you have infinite scroll, right, does each little, row of information constitute a page? Or does like a full new page constitute a new page? Since people don't necessarily scroll that often. Um, On the other hand, on the desktop, right, the page view has lots of information. You're consuming a lot of information at one go. So what exactly is the trade-off between a page view on a mobile app versus a page view on a desktop app, right? And do you want to, push your users into one experience versus the other? And that's very hard, right? And then at the end of the day, you need to just report, we've had 2% more page views than last year. How are you going to define this page view, right? Because the teams will then get different share of credit depending on how you define this. And so that data protocol is actually very tricky. Um, and a lot of people often think about this, I would say software developers, I should say, think about data more as a logs to track errors or track progress, efficiency, so on and so forth. They're not really thinking necessarily like the end decisions that need to be made when they're defining what data to track. One other fun one, I would say, if you're lucky, is to actually productize your models. And so when you think about this from your linear regression model, for instance, you have coefficients that come out, you have predictions that come out, you have uncertainty associated with the prediction or the coefficients, right? Each of those things can be productized. Um, and it's usually users don't want your entire model, right? If you're a data scientist, like, well, I've trained the model, here you go, here's the model. Um, that's not good enough, right? Because users already don't quite understand uncertainty. Believe it or not, scatter plots are actually very confusing for most people, just because the axis, and things, people are just a little bit overwhelmed when they see too much data. So how do you convert that into a consumable product, right? And that's where interaction often with designers, product designers, UX designers, product managers really come in. And if you can be part of that process, that would also be pretty fun. The next one is pre-processing. So a lot of you already know probably like how handling missing data is quite critical, right? In terms of later how the model will handle these situations. But along the pre-processing comes a little bit of a data protocol. So one example you can hear is in a software develop in a tech company in general, if you're deprecating a service, so meaning if I have a API, that answers all the questions related to LinkedIn news, right? And suddenly I have a new platform that can somehow aggregate not only LinkedIn news, but people who are paying ads to us and put the ads and the news kind of integrate with each other, right? What needs to often happen is that you want to get rid of the old service and just run the new service, but there's like a transition period between this. And that transition period, most people think it's just codes. You just like flip the on and off switch and it's just done within a week, maybe if you're sad, if you're slow. But no, these things often take a year. And so during that year, your data is going to look a little bit weird because one service will probably track data very different from how another service tracks data, because all of a sudden you have all these new fields. You definitely want to differentiate your news articles versus the advertisements and sponsored content. And so that type of pre-processing, again, doesn't come naturally for people to think about, well, how will decisions be made off of this? They're often just trying to track the health of the system. And lastly, there's a support team, right? If something crashes, the support team will call someone and they're really going to need someone to kind of understand this kind of end to end of like, okay, something broke, customers complaining, where do I go to? Do I go to the analyst? Do I go to the product manager? Do I go to data scientist? Do I go to the data engineer? Do I go to, right, the backend engineer? Things like that. And I would say data scientists, you really need this end-to-end view from a very quantitative perspective of how each of these decisions will affect the end product and the user at the end of the day. Um, and any individual layer, I would argue, is actually slowly being automated away, right? People are collecting data, I would say, more and more automatically. When you build a website, a lot of default tracking just already happens. People are building models, with very powerful, I would say, libraries already. Um, and a lot of MBAs can productize models already. They're actually quite quantitative, and analyst jobs are also being slowly chipped away. So if you do want to become a data scientist, I would argue you really need to have this end-to-end view, because right now tech companies are very much structured like software development teams. You have different silos, and the product manager's role is often viewed as to kind of link all this end-to-end work together. But I would argue that it's also the data scientist's role, because you can view things not from just like a get the product through, make sure the product is running, but you have this quantitative data perspective about it. I would say that's like the classic kind of data science and tech role. Okay. Um, and then obviously the fun part comes in once you have multiple products interacting with each other, and all kinds of data quality funness happens at these cases. Um, so that said, I would say one of the key mistakes, I'm going to move on to mistakes um, outside of tech and tech mistakes. I would say the first one is often this idea that once you have the data, you don't need the experts anymore. So we often see this a lot where the data scientist newly hired into the company, which is like, well, just give me all the data, right? Just give me all the data, and I'll just figure something out and I'll make some magic and life will be great. Okay. Never works out that way. First of all, for anyone who will say, give me all the data, means you have not actually worked as a data scientist before, because the definition of all the data already means you don't understand um, what you're asking for, really. But not only that, why experts are necessary is that a lot of the data is collected by forces outside of your control, or it's measured at things that you don't anticipate. So first of all, often, at least in farming and manufacturing, there's a physical process to the collection of data. So here's an example of a soil probe, where you basically push this little kind of hollow tube down the dirt, and you pull out a vertical profile of the soil. This can be done via hand probe, which is what you see here, or there's a machine probe that kind of pushes down. And believe it or not, that the data collected by these two different measurements are very different. So the machine, I think, actually has a little bit of extra compaction, like the dirt's actually more packed up. And so that actually creates a very different understanding of what the soil is like. And if you didn't know about this and you saw the end data and you didn't know how people collected the data, this would be very surprising to you. Different labs use different methods. So if you actually have a chemical measurement, turns out different labs use different measuring processes, and different labs are only operating in certain states. So we actually had one protocol where a particular large farmer had farms across different states, and they sent different samples to different labs in different states, and we got drastically different measurements, even though things were treated completely the same and the soils were very similar. And that was quite surprising as well. Another thing is that equipments often have limits, and they're designed. So here is just kind of a demonstration. Imagine a fertilizer, right? A machine that's spraying fertilizer down onto the field. It usually has a range of like what's the maximum output it can support. And if you try to fertilize at the maximum capability, you'll actually see a lot of variability. Um, just because like the machine's probably, pushing all the fluids out and then it's losing the pressure. And so you'll suddenly lose um, some kind of application and it'll recharge the pressure and go back up again. And these type of phenomenons exist, and it's really hard to differentiate, what is from the equipment versus what is from the heterogeneity of the soil itself, or is it the driver that's causing this, or is it the internet connectivity went wrong, and so the data just looks a bit weird. Um, so these things you really need the experts kind of helping you look at the data. What I like to do is I create just graphs of just like, this is what I am seeing. Can you tell me what you see or whether what we see are the same thing? And a lot of knowledge about just like how does um, the variability comes about really comes through. And these are very, very exciting conversations, I would say. And the last one's actually a fun one, um, that there are constraints in data collection. So one example is we were trying to um, measure the soil fertility. So specifically nitrogen in the soil over summer. So we were looking at the data for particular fields, and we realized there's a lot of data in spring and there's some data in the fall, but there's no data in the summer. But the summer is when a lot of rain happens. It's extremely dynamic for how the nutrients flow in the soil. So we're like, well, we obviously need more data in the summer. Let's just spend more money and get data in the summer. And so when we proposed this, the farm managers laughed in my face. They're just like, you come down here and you go collect data and you will realize why we only collect a little bit of data. And they say, if you force us to collect data, you're just going to get a lot of bad fake data. And the reason is that it's extremely, extremely miserable in the Midwest and your cornfield in summer. There's pollen everywhere. It's extremely humid. You can barely breathe. You're wearing this full-on suit. Um, and so when the people that they employ to collect this data, if you ask them to collect really, really fine detailed data, they say it's very likely, more often than not, that people just collect data on the outside of the field, or they'll just write it in. They'll make up numbers for you and just give you that data. And so these really create some kind of constraints in the data, and these are good to know problems before you actually just spend money and pretend that the crowd's employing people will just work out. The other mistake I would say in tech is this concept of disrupt everything, right? There's always this concept of moving fast, but existing business processes often exist for a reason. Failing fast only makes sense if the cost of failing is low. So at UTC, we're building parts for planes, and so a bad engine literally would crash a plane, right? Fortunately, planes have multiple engines, and you just need one to be running for it to keep going. On the other hand, right, if Twitter goes down or something, it's just an error message page, right? Like you can't access Twitter for a little bit or Facebook, and your life will likely move on, and that is okay, right? And I would say a lot of people um, sometimes don't quite understand how bad things can go, right? And I would say that's just something you need to be a little bit more careful. And regulations exist. So when I was working at UTC, there were some very sensitive data, and two data sets could only be on the same kind of device um, for a limited time. And that person with that computer had to face a wall so no one could see their screen from the back of them and things like that. These were actually spelled out in the agreement for the opposite team to share data with us. And these regulations exist because um, people have stole data, and corporate espionage and things like that have happened, which is sounds crazy, and you feel like that's not going to happen to you because I thought so, but actually no. Like someone I worked with is under an international lawsuit now about stealing corn hybrid data, and so these things you do want to be very careful. And I would actually say you should use these regulations as kind of opportunities rather than um, blockers. So I view these really often as constraints that make the problem even more interesting, right? So how do you use the only necessary pieces of information, respecting the regulations, yet still developing a product? Um, and these regulations are often built with the idea that they still want to encourage innovation. So if you ever work with kind of a regulation compliance expert, the first thing that it will say is like, we are your friend. We are not here to stop you. We want you to do your job and be successful. However, we are also here to warn you of the mistakes that can happen. Um, and so, yeah, you can't just disrupt anything because you could be locked up. um, and I don't know if this slide actually moved on. Okay, sorry. I would say another um, piece that often happens that is confusing is people hire data scientists in these classic industries, okay, like agriculture and heavy manufacturing, because they want you to complement the existing business, okay, not disrupt it. And so, what the classic story or the classic tale that I always hear is that they hire someone with some kind of data science background or machine learning, and the person, grabbed all the data, they fitted a model, and the model is amazing. Why is it amazing? Because within just a few months, the model has reached similar conclusions as the classic team, the classic group of scientists have reached that they spent years to reach, right? So they might have spent 2 years to reach some kind of understanding of a process or phenomenon in farms. And this machine learner came for just a few months and they reached the same conclusion. And well, if I can do 2 years amount of work within just a few months, like why wouldn't I do that, right? So they're like, oh, great, let's throw more money into this machine learning aspect and these teams. And what happens often is that the machine learning teams will very, very quickly, right? I would say reach the same amount of knowledge that the existing scientist teams have, but quickly plateau, quickly flatten out and be like, well, what are the other questions we need to be asking? Uh, what is the new data that we're supposed to be getting? And the answer is the data doesn't exist, right? The old teams, the classic teams that have been there have already collected the data for you. They've asked a scientific question already. They knew what data they want to collect. And that's why that data exists. And it's really easy for you to kind of back out those same conclusions. Um, but it's really hard for you to innovate beyond that if you just stay within that silo. Okay. And really, companies, these executives are hiring you not to replace the existing team, but really hoping that you'll complement each other. Um, um, yeah, so they want you to stack on, not just like rebuild another pyramid. I guess this is kind of the imagery I was going for. And the other piece is that trust in you and your data is vital. So this sounds trivial, but is actually surprisingly violated a lot. Um, so imagine a new employee coming in, right? Completely disregards all the old experts' opinions, builds their own data, builds their own, workflow, etc., and comes up with a completely different conclusion than what the previous team was saying. You haven't really built your credibility or your trust, even if you are right, right? Um, People won't employ your model, your workflow, your whatever. Um, it's because you need to gain people's trust first. And so when your attitude going in is just about disrupting everything, everyone who's worked before on this project is outdated. They don't know what they're talking about. If that is your attitude, people won't trust you. People won't work with you. You're not going to understand the data. You're not going to understand the business. Um, and it doesn't matter what you say. And if you ever lie, which sadly happens every now and then because people want their product to look better in the testing phase. Um, and when it goes out in production, things always crash, right? But people tend to have this, I would say, bias to make their product look better than it really is. If you ever lie, people will start doubting all the analysis that you've done in the past and all the data that your team is creating. And so you really, really should avoid doing that. And again, this idea of disruption of like, okay, if we just get this product through, the customers will love it the moment they see it. Yes, that maybe was the Steve Jobs attitude on things, but not all of us are Steve Jobs. Okay, so I would say just be a little bit careful there. Okay. Okay, so sorry. So another mistake is I would also say not understanding the business. And I know a lot of, I would say, academics really hate thinking about this, right? Which is like, how does your company and team make money? So when I founded the data quality team at Climate Corp, I had two employees at the beginning, and I had to calculate what is my salary plus their salary, and is our team actually producing that much money for the company? The company's not keeping track of this. My manager wasn't really keeping track of that. However, I knew deep down that we needed to justify that number for our team to exist sustainably and also to even expand. And if you ask around, a lot of people actually don't know, especially in the larger companies, how their team makes money. When you reach a company of Google size or Facebook, etc., sometimes you are in some niche research team, and you ask, well, how does your work how does your salary, right, actually translate into money for the company? Is it through marketing, right? You do AI, so your marketing team can say you guys have now AI capability, or is it because you're improving ads? Are you improving, you're selling a better product? What is it, right? And not a lot of people can answer this question, which is somewhat dangerous, I would say. Um, Also, understanding the elements required to deliver and maintain a product. So a lot of people think you get data, you train a model, someone in the software development team will just push a button, it's launched to the world, done, right? Code is automatic. No one needs to maintain code. No one needs to be looking at the data after it's launched. We already done our cross-validation. Things must be the same, right? That's not at all the case, right? Remember the t-test that I said at the LinkedIn A/B testing platform, right? I thought that would just take maybe a month, right? 3 months at most. It took an entire year, not only to just get all the bugs out, get an FAQ, get the different teams to trust us, you know. So there's again this idea of trust, right? When you deliver a new product, you need to get it into people's hands for people who are willing to try things, and you need to then gain their trust. So they'll keep using it and tell their friends to use it, and then they'll also onboard, right? So maintaining that requires a lot of effort with people with different skills, right? Because I know how to triage problems for an A/B testing platform, but I may not know, you know, how does the A/B testing platform hook in to the recommendation system that the other team is building, right? And so these are things that you need to just be very careful of. How does the business actually run, and what is your role, and what are all these supporting roles behind you that are delivering a product? And especially in a classic industry, I would say this is extremely easily lost. So in heavy manufacturing, it's like hyper optimized, right? The Six Sigma and all these, made to order type of frameworks have really compartmentalized people's jobs kind of away. And so a lot of people actually aren't aware of what the other teams are doing. Um, and this has created, um, some efficiency, assuming things really work out. But at the same time, people start not knowing, well, what does it take to actually deliver the whole end-to-end product? And that's really honestly where a lot of, I would say, the innovation can come from, is again, understanding that pipeline. So, oops. So what I really advertise that your role would be in a classic industry, or so I would say outside of tech in general, your first role is likely to empower the existing experts. Okay, so you don't want to replace them. And I know it's surprisingly tempting when you're a data scientist. You're like, well, once I build this thing, you don't need your old team, right? And that's where your money savings is going to come from, is that you don't need these other people because people cost a lot of money. But I would say that if you ever enter a company that's outside of tech in general, don't try to replace the experts. Empower them with data science practices and tools, right? Like databases, like a lot of people are still sending Excel sheets through email with each other. Don't do that, right? A lot of people's code is still stored on their local laptops, not reviewed or shared on a public, not a public, but a within company GitHub repo, and things like that. There are a lot of better ways to handle code and data that I would say the modern era can provide than what people are doing. And don't be like this person here, right? When you're reviewing someone's code, um, you're not being helpful, right? I really try to empower folks. And other practices are like, um, what is it? Like the agile methodology, right? Classic industries often do a lot of waterfall strategies. If you don't know what agile is, don't worry, but that's a whole nother talk. How to basically do incremental improvements and be fast. Okay, and the next one is to really think about how to monetize data itself, right? So you want to innovate with data as a primary asset, not necessarily as the kind of, again, a derivative or just a log. Um, so if you can somehow let a team uh, make money not only with the existing product that they were producing, but somehow sell their derivative data as well, you are justifying your role already, right? And people often don't know that. Why would you want to read my logs, right? Like, why would you want to read these logs that like I barely only look at unless there's a problem? And that's where I would say a lot of the kind of innovation can come in is that, people don't know once you connect the data across multiple sectors that a lot of value can be generated. Okay. And the other one is to facilitate. So again, when you work right from the field, right, someone's driving a tractor across a cornfield, collecting data, sending it to some third party, website, gets translated to your company. Your company then delivers it. Then there's a support person trying to talk to the customer about this data. When there's this like end to end, just like all kinds of people, all kinds of disciplines looking at this data, terminology gets really mixed up. Okay. And so the word quality alone is just like such a loaded term in every field that it means something different to everybody. And so really trying to understand like what does quality data mean to different people? And does it matter if it's bad to the end user? Okay. That turns out to be a very difficult question. So I find myself a lot of the times is product manager would just be like, okay, this person just said this, and you are saying this, or that other person is saying that. These are all the same words, but I think you all have a different idea. What is that? Okay, and I would say statistically minded people are surprisingly good at differentiating these things because statisticians often have structural uncertainty, variability, from stochastic sources, deterministic sources, like your model and things like that. So statistically minded people, I would say, are actually very fluent in this translation. So that's hopefully a good sign for all of us here. So a few opportunities I just want to kind of emphasize is that there are plenty, and I mean plenty of cool data science problems in classic industries outside of tech. Okay, so managing data is still new. How do you do inventory on data? Who has a monopoly on data? Right? We kind of intuitively have these ideas, but we actually don't have a formal framework for this. Um, and how do you sell data is also a question. How should you price it and things like that? Um, I would also say a lot of places be innovative. Causal inference to me is like absolutely the future outside of, again, in these classic industries, because previously there were a lot of scientists understanding, right? What is the process? What are the factors that influence, more corn yield, um, better efficiency planes and things like this? And so surprisingly, a lot of causal inference techniques can come in to play here. Interdisciplinary data is also super fun. Like a lot of people right? Aero engineer, the QA engineer, so on and so forth. Again, they work extremely separately from one another. And if you are able to somehow put all their data together and actually amplify the value there, it's actually a very, very interesting space to be in. Uh, Another fun one is that classic industries will likely exist beyond 100 years, right? So there are a lot of friends that I have who were previously at Zynga, right? A lot of games that they built back in the days don't exist anymore. So all that work, all that analysis that you've done kind of just evaporated in some sense. Whereas these classic industries, if you found out, right, how a type of management system with a different type of soil, with a different type of hybrid works together, that is knowledge built and accumulated. And that is much more satisfying for me personally. And you get these nice patents that, actually do something in the future. So that's fun. Um, Combining data with existing knowledge gives you ground truth. And this is, I cannot tell you how beautiful that is, right? At LinkedIn, you would often have product managers ask you questions way, way back in the days. Like, are users happy using our product, right? Are they obsessed with it, right? Do they need it and things like this? These are very vague questions that um, it might be true at one point, but people move on because people, right? People's preferences are kind of non-stationary, I should say. And this the idea of ground truth is really hard to get. You can't really put a survey up and be like, how much do you love our product here? And that's really difficult. Whereas in classic industries with actual science backing things up, you do have ground truth, right? At the end of the day, the corn plant has a certain weight. The plane is running for a certain amount of time. Can have quite specific measurements for when an actual event happens or what is considered a ground truth. This is still tricky for those who have actually worked in this space, but it is much, much better than tech. Tech is you create a universe completely, right? You create what people can click on, what can they see, what can they transition from, how long can they be in different sessions and things like that. You control the universe. But even with all that control, you don't quite have the ground truth of how is the user enjoying this, right? You can't measure happiness in some sense. Um, and I would say a lot of the classic industries are actually more inclusive than you think, right? I am personally guilty of this before entering the farming world and manufacturing, thinking that they're extremely outdated. Um, but turns out they're not. A lot of people are actually very aware that they have um, a lot of young people aren't working on the farms anymore. And because of these phenomenons, people are actually really asking really hard questions about how can we keep the talent coming in. And there's actually a lot of, I would say, programs that facilitate young professionals to enter their fields. Um, so UTC, for instance, had a newly grad from undergrad, and they would let you rotate through different roles. You would try out being a product manager, be a project manager, be a software developer, be an analyst, and they let you rotate through all of them. At the end of the day, you can choose which team you want to join, and they will guarantee you a job. Um, and so these are extremely nice programs that I would say y'all should try out if you qualify, obviously. That all said, right, there are some things I want to warn people about. Um, so there are companies that you should avoid that are outside of tech. Um, so the first type is I would say companies that don't have any data, right? If it's like a super newly found company and they don't have a single bit of data and you are relatively new to the field, you should run. Because collecting the data, having a data strategy meaning, well, when you first get the data, you're not going to make any money off of it. But what is your strategy to eventually create money out of this data? And it doesn't have to be necessarily money paid to you, your company, but it can be just value generated within the company, meaning, are you making faster decisions? Are you making better decisions? Are you making more decisions at scale, right? And efficiency just internally to the company can be valuable. But if you don't have any data and you have to start things from scratch, literally from measurement to storage to delivery and all that whatnot, that takes a lot of work and a lot of experience. So I would highly discourage people from entering these fields. The reason some companies also need to hire a data scientist or an AI engineer to join their company when they don't have any data is that their investors want to see it. The investors want to see that you are investing in AI capabilities, otherwise I'm not going to invest, right? So they just need someone with that title to sit there, and you're just kind of spinning cycles, and you're going to go in and be like, do we have data yet? Do we have data yet? I came up with this plan. We should collect this data. Okay, we're not going to get that data because everything else has a higher priority than getting the data. That's a problem. You shouldn't join that company. The opposite problem turns out to also be true. If there's too much data, or they're claiming they have too much data. So I've interviewed at a company once that they had all the public data sets in the world. They said, if there's a public data set, we have it. And my first question was, how do you organize this data? Do you have a data architect? And the answer was, no, we don't have a data architect. Our software developers know how to organize the data. Um, at that point, I knew they didn't know what they were talking about, and you should just run as well. Um, and that is just that these people are likely using this volume of data as a marketing scheme, not that they actually have a way for you to query and use their data efficiently. There's not a single place you can probably say, hey, let's grab this data with this data, and it's already standardized, etc. They don't actually know what the data they ingested means. Um, Things are probably not in the same units if you have data across different countries, etc. So those are, again, just not good signs. Another company issue point is the data that companies that use data to support existing opinions. So one question I would encourage you to ask during an interview is just, when was the last time your company changed a decision based off a piece of analysis you provided? Okay, and that's an easy, I would say, straightforward question. Um, and if they can't really give you one, that's probably not a good sign, because data rarely always reports good news. Data often um, dampens people's expectations, deprecates products or whatnot. Um, there should be plenty of opportunities for um, analytics to provide a decision change. And so if they have never done so, that's also a negative signal. A common one, and people have asked me this in the past, is that if I see a company, a startup, for instance, that has equal, let's say, number of data scientists to software developers, you have too many data scientists. If you have the same number of data scientists as data analysts as well, you're probably also having too many data scientists. So too many is definitely a subjective term. I will agree with you. But in general, you can't have that many people trying to be innovating and pushing out products all at the same time. And that creates problems. Why? Because if I build a model, you build a model, we both want to push this model out, the company rarely can support that. First of all, do you have that many users to try out your product, right? If you're at Facebook, LinkedIn scale, sure, right? But if you're at a startup scale, you only have a precious few number of users. So you can't actually be rolling out that many tests in general. Also, so that creates often a queue. So, well, I finished my model first, so I'm going to push my model out first. We're going to try it on a few users. The other data scientist has to just wait, right? And once mine has been tested out, updated, etc., the new data scientist has to then push out theirs. Um, and so this queue creates a problem, right? Because different teams now start pushing out things very, really slowly. And so you'll be spending a lot of time just kind of spinning and not necessarily doing actual, I would say, productive work, which can be dangerous. Another one you also want to avoid is, I would say, just certain managers. So data science managers are actually quite new as a role, and they're actually very hot because it's really hard to hire for. Because a lot of people try to become data science managers from other disciplines, and I would say don't quite do so great. But a way to identify these managers is first of all, just ask them to articulate, well, what is the role of a data science manager? How does that differ from when they were practicing as an individual contributor, right? How do they see their role relative to the team? What do they do from a day-to-day versus, I would say, even other managers? And what is their view, what is their vision of the initial project when you start onboarding onto the team? If they can't actually articulate these, assuming again that you're a relatively junior data scientist, um, that's probably not a good sign. And why is that? Because if they can't articulate an initial project for you, that means you're going to have to come up with your own project yourself. But that requires you to, again, understand how the business runs, understands how models are pushed into production, understand how to test these models, understand where to even get the data, or what is the correct logic to process the data, et cetera. Um, and, and, and yeah, there's just a lot of problems that I would say can happen if your manager doesn't quite um, have that vision, especially for data science teams in general. Okay. And there are other ones if you want to talk more about, but that's that for now. So that kind of concludes my talk. Um, Hopefully that gave you some questions that you might want to talk about, but I can be extremely candid here with all of you. So since I've left tech for quite some time at this point. Yeah.
Wow, so much good advice. Thank you, Wayne. So I'd like to invite all of our attendees to either write some questions in the chat, or since we have a small group, if you'd like to use the raise hand feature, if you click the little hand, I can allow you to unmute and we can have some discussion. So while you all are thinking, I'll get us kicked off. I loved your advice about learning the financials of the business side. I think, that's good advice for anybody. I'm in academics and I'm still figuring it out. So I'm wondering if you can give some advice, like how do you even approach that? Like say you're new at a company or in a new position, like how do you go about figuring out the financials and how everything works?
Yeah, well, the first thing you should do is ask your manager, I would say. That's assuming your structure kind of works that way. Another a common structure for companies that you're embedded on a product team. And if you're embedded on a product team, you should ask the product manager. Um, One thing I would say not to ask is the software developers sometimes. Sometimes they know the answer, sometimes they don't. And the reason I say that is that software engineering teams can justify their value simply by making sure the lights are still on, right? If 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 the data isn't flowing, if the website isn't loading, the company won't make money, period, right? And so their role and their I would say service can be justified by simply making sure things run. And you as a data scientist can't work on that same logic because you are in some sense, I would say often a nice to have. Startups, again, they often already have an existing product idea that they want to execute. And so before they even ever productionize, like usually there's an MBA that's really smart thinking about, okay, how are we going to get people to eventually pay for this? Um, and so I would say, honestly, asking is the number one. And number two is to come up with ways yourself, right? So a lot of companies, how they monetize, I would say, are relatively obvious nowadays, right? Ads, for instance, if anyone plays a mobile game, you see games advertising for other games, and that game probably advertises back to the other game, and they're just paying money back and forth to each other, right? Google obviously monetize or trying to monetize their Google Cloud, right? They see AWS making so much money, and they want to make that much money, etc. So a lot of these, I would say, are um, you can just read a few articles and just ask, can we make money the same way? I would say that's the first place to start. And the second one is really just ask, like, what are the major pain points? And I would say there's a lot of decision making, believe it or not, that is being made on a very, very ad hoc, intuitive basis, especially in these classic industries. A lot of people are like, well, we've been doing this for 30 years, and so we keep doing this. Or if we've done the optimization once 20 years ago, and things are still working, so we're not going to touch anything here. Um, and So sometimes just re-asking, being the new person, I would say, especially when you're new, if you have this new card that's, out of jail free, you just keep asking, sorry, I don't know, how are we making money again? What is your understanding of how we're making money? Sometimes asking just different people in different roles how you're making money will give you a better picture of how money is created. And believe me, like, people answer differently. And that's, again, I would say data scientist's role, which is to piece together all these kind of seemingly incoherent data and making a coherent story by, okay, now I know how. And sometimes the answer is no one knows. And if that's the case, you should just be aware like how much more investor money you have. So, yeah.
Yeah, I like that idea of asking multiple people. I also think it's just really hard when you start out, especially as your first job. You don't really know the right questions to ask. So, I like your suggestion to like keep at it and, like things are constantly updating. So you should be keeping on top of it too.
Yeah.
Um, so how about another thing that I really resonated with that you said was that we as data scientists and statisticians need to get people to trust us. And so I'm wondering if you kind of have some strategies that you can share that you've used, or especially at the beginning of your career, you're not as confident in yourself or your abilities. Of course, we all make mistakes. We're going to make mistakes at some point. So can you kind of give some strategies for building trust and then maintaining it throughout your career?
Yeah, I actually had a few very influential turning points myself. I would say coming out of statistics, um, and I think this is still a little bit true, where statisticians have a reputation of tearing people down. I would say there is this kind of joy of like, oh, being in the right and just being like, you're wrong. I found the weakness in your argument or your paper or your analysis, and here's why this doesn't make sense. Um, and while that produces papers and critiques and et cetera, and some kind of buzz, you're not being constructive. Um, and I have found myself doing this one time with an analyst, and I was just saying, your analysis doesn't make sense. This data doesn't have all the data. These numbers, really, you're just making up these numbers practically. And my teammate was like, hey, you're not being constructive. Like, what's going to happen after you said all that stuff is they're going to not like you, but they're still going to present the numbers because you didn't offer them an alternative. And where they're presenting the numbers, you're not going to be there to stop them. And so for you to actually make true change is that you need to offer an alternative to saying, okay, you can't report those numbers, but here's an alternative that you can. So once you provide these alternatives, you think for other people, people will start trusting you. I would say another advice I got that was really good is never tell someone to do something that you are unwilling to do yourself. So literally what I do a lot when I first enter a job is I try to dig in, well, because I often have to interact with software development teams. My first question is like, how do you push a comment into production? Right? So how do I add just like a little bit of a little bit of comments in, which requires me to get permissions, learn how to do a review, and basically, get it launched and tested, etc. Make sure you didn't crash anything. And when you go through those steps of what the other person's job requires to make what you think is simple, you're like, hey, just push my model out into production. It's not that simple, right? It's they have to push it to testing, they have to run a few tests, and they have to do some integration tests, and then they push it to the next environment, and then it gets a product. And sometimes there's data that changes and they have to backfill everything, which might take days or months even. So if you don't really understand what their job takes to do things, or even customer service, I would say is one of these as well. If you're unwilling to have a phone conversation with a farmer or customer, you shouldn't be telling people to do certain things. And that's the attitude the farm manager took with me. She's like, if you will come to our field and hand harvest or push those soil probes down in the summer with that mask on with full of pollen, be my guest, right? If you do it, then we'll do it. And at that point, you're like, okay, if if all of the farm managers telling you this is not a good idea, you should probably trust them. Um, so I would say those are, I would say, ways to gain trust. I would say I'm also trying to kind of push a few things now that I'm an educator, which is, I think, number one principle, data can't answer all questions. Trust is one of those. People don't just trust you based on data, right? You just be like, I worked at these places, just trust me. Some people will, but I would say most people don't. They want to see you face to face. They want to talk to you. And that's not a data problem. Number two, I would say you need to be very creative with providing alternatives or providing ways for people to leave a very awkward conversation. So for instance, if people are presenting something that you just think it's wrong, right? Don't just say like, this is wrong, right? Be like, hey, I see something's a little bit weird here. Could it possibly be that, maybe the code ran and filtered out these fields and only has this result? Can you just double check this? Like give them a way to exit a very awkward conversation, but that requires some creativity for you on the spot to come up with legitimate alternative ways. It can't just be completely made up. And the third one I would say is to have the discipline yourself to ask, well, what data would change your opinion, right? So if I have a very strong opinion and someone is trying to change my mind, I need to be able to tell you, well, for you to change my mind, I need to see A, B, and C. That requires discipline on my part, being like, I know what will change my mind. And if I reach the conclusion that no data can change what my opinion is, I am not being cooperative here. Um, and I would say that is something that surprisingly statisticians are best at, um, because you often think about uncertainty and very bad data in general. I would say a statistician tends to be the best, whereas most other professionals I've worked with need you to be providing them. You would actively say, if I provide this data to you, would this change your mind? Well, if I provide that to you, would that change your mind? And the answer is always, we will see, right? But you can kind of get a sense according to their tone of, okay, like, yeah, maybe if you show this is true, I could think twice versus we will see, like go spin your cycles. I'm not going to change my mind. And I would say that again, just makes you a more, um, let's say, constructive individual, a much more of a team player. And I know data science classes are often taught, you get your data, you do something, you push it out. Um, you really can't think that way. You are a person and an entire team, and ask yourself, like, what are you supporting your team members? Do you trust them, and can they trust you? And it seems simple, but it surprisingly isn't, especially coming from the stats world, I would say. So, yeah.
Yeah, I definitely agree with your sentiment about statisticians can be a little harsh. I'm not sure if you're on Twitter, but I've seen people get totally trashed based on statistics stuff. And I mean, I agree often, but I feel bad. I think, there's better ways to communicate about it.
Absolutely.
Yeah,
Absolutely. Yeah.
yeah.
And
So I had one last question that I thought of. I thought it was really neat, that you're taking kind of a newer field, data science, and connecting it with some of these classic industries that really, like agriculture. Some of our first statistical models came from problems in agriculture. So I think that's really cool that it's kind of like coming full circle. And I'm wondering what advice you have for people who are maybe in undergrad now or looking into graduate programs. Like, should they take a more traditional statistics route or a data science route or like some combination of both? Like, what skill set do you think is needed in the industry now? And what's the best way to get there?
yeah, very, very good question. Um, so honestly, a good data science curriculum, I think, would be best, but I don't think I have seen a perfect data science curriculum, or not a perfect one. I would even say a satisfactory data science curriculum, at least so far. And reason mostly being that most instructors just haven't had the data science exposure usually. Most people tend to be relatively more academic or had I would say, researcher role within a company, not a data science role in a company. And those are very different because if you're just a researcher, you're given the problem. You have a budget to collect the data and you're just there to just solve the problem. Whereas a data scientist, you're kind of like trying to figure out, well, how do I sell the data? Um, which I would say is a very, very different role in general. Um, but you do need a somewhat sprinkle of topics, but mostly things like you need to know linear models for sure. You need to know computing. Let's say you need to know a little bit about optimization. And I would actually encourage the students, to take a few humanity classes, to be very honest with you. A lot of the STEM programs are now so large that people barely get to talk to each other, and the assignments are designed in a way that you kind of don't need to interact and move forward. And I've seen students who do group projects, and it's just like, you make your version, I make my version, then we'll just try to merge them together at the end of the day. And those don't quite create a collaborative discussion. And there's such a fixation on like what is the right answer, that I think people start losing sight that, there is a lot of freedom here. Humanities, on the other hand, I think do a great job of this in terms of encouraging discussion, having small groups, allowing different perspectives to all be correct. And that is surprisingly, I would say, more realistic to how the real world works, because data is, so messy and often just pointing in different directions, like that. Machine learning classes, you do need to know the most basic ones, right? Like, surprisingly, like, cross validation is so intuitive. Like, everyone understands cross validation, even if they've never learned anything about machine learning. So those are, I would say, very useful, I would say, concepts to do and try. You need to know hypothesis testing. Deep learning, etc. topics, I would say, are nice and fancy. And they're nice to have because a lot of, maybe, I would say, older professionals like myself, I'm not old, I would still say I'm saying young, but I definitely graduated before deep learning was a big thing. And so, I feel like there's a little bit of missing out, right? And maybe there's something that people are teaching in classes that, you know, are better. And so sometimes having a bit of background on the new stuff is good, because, we want to hire new voices to be like, oh, I've seen this in my class, that we solved this really well with this algorithm. That has happened every now and then. It happens rarely, though, I will tell you. I would say like 99% of the problems can be solved with the most classic methods. And they're way more robust, more trustworthy, easier to debug, easier to interpret, etc. Um, and also easier to know when to stop. That is a surprisingly hard question. Like, when do you stop your analysis? Because it seems like you can write your dissertation forever, but a company needs you to wrap up a project within 3 months, right? So when do you make those calls? I think are hard. Um, but to just go back to your question, right? Um, Computing, basic statistics, one flashy title, probably, humanities, and I would say a business class. People often not try to, but I would say some people look down on MBAs and business majors, etc. But they are extremely sharp, extremely intuitive, and very practical, right? And obviously that's a nice attitude to have when you've been trapped in academia a little bit too long. Um, yeah, so that's that.
Yeah, I think that's great advice. And it's funny because you basically just described my education. So maybe I should
Oh,
have gone into industry. But
awesome.
yeah, I mean, that's really I think I really like your advice about including the humanities and the communication skills, I think, that are often overlooked, and that a
Mhm.
lot of people in our field probably can use and benefit.
Yeah, cool.
Yeah. All right. Well, I don't see any questions from the attendees today. I guess everyone's being
No worries.
quiet.
Yeah.
But Wayne, again, thank you so much for this wonderful talk. I feel like I got a lot out of it. I think I say that every webinar, but I really enjoyed your talk. I think, you had so much good advice. And I'm sure a lot of people will watch the recording.
Awesome. Thank you so much.
Yeah,
Take
thank you.
care.
All right. See
Bye.
you next month,
Bye.
everyone.
Bye.
Bye.